Hi students, once again I welcome you all to my channel Abrar sir classes. ಇವತ್ತು ನಾವು ಕರೆಂಟ್ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಚಾಪ್ಟರಿನ ಕರೆಂಟ್ ಆ್ಯಂಡ್ ಡ್ರಿಫ್ಟ್ ವೆಲಾಸಿಟಿ ಟಾಪಿಕ್ ಮೇಲೆ ಪ್ರಾಬ್ಲಮ್ಸ್ ನೋಡೋಣ. This is the first problem. It is saying like this: a wire has non-uniform cross section as shown in the figure. Okay, as shown in figure. Now this is what non-uniform. Okay, what is meant by uniform cross section? If you are having this is uniform. Okay, if the area is uniform, then it is called uniform cross section. But ಇದು ಏನು, this is called non-uniform cross section. ಇಲ್ಲಿ where as we move from P to Q, area is increasing. Area of P is less than area of Q, or else I can say that area of Q is greater than area of P, right? Okay, now a steady current flow through it. The drift speed of electrons. Okay, what is drift speed? Okay, we know that I is equal to current I is equal to V napa V E N A V na. Okay, where V D is nothing but the drift speed, right? Okay, now he's asking the relationship between drift speed and the area. Now I can write V D is equal to drift speed is equal to I divided by ENA. So we came to know that VD is what? Inversely proportional to area. Okay, as the area increases, what happens? VD decreases. As the area increases, VD decreases. What happens here? Whose drift speed is more? Here, which is whose area is more? Okay, area of Q is more compared to P. Therefore what happens? AQ, we know that AQ is greater than AP. Therefore drift speed of Q will be less than drift speed of what? P. Okay, therefore here VP will be greater than VQ. VP will be greater than VQ. This is the right answer. VP is greater than VQ is the right answer for this one. Next problem nodana. In a wire of circular cross section with radius R, okay, free electrons travel with a drift velocity V when a current I flows through the wire. The current in another wire of half the radius. Okay, now we know the relationship between current and drift speed, right? I is equal to Vena, VENA, where VD is nothing but the drift speed. Now what is saying that drift velocity, okay, what is drift velocity is given by VD is equal to I divided by ENA, right? Now he's saying that the current in another wire, okay, of half the radius. Now I can write, okay, this is different thing. Now to calculate VD, we have to use this formula. Now he is saying I is equal to VD into E into N into pi R square. Area is nothing but pi R square. Now in another wire, okay, of half the radius and the same material, when the drift speed now I dash. What he is doing the second case, he is increasing the drift velocity to 2 VD agutte, and now he is reducing the radius to half. 2 VD into E into N into pi. Here this will be R by 2 agutapa. Okay, because area is getting because radius is getting reduced to half. Okay, that is area is nothing but pi R square, and here radius is getting reduced to half. Now it will become how much? I dash 2 VD into E into N into pi R square by 4 out by 4. That is nothing but I dash is equal to VD E n pi r square by 2 ಆಗುತ್ತೆ. That is, we know VD E n pi r square is nothing but what? I by 2. Therefore, here I dash is equal to I by 2 ಆಗುತ್ತಪ್ಪ, right? I dash is equal to I by 2 is the right answer. Okay. Here you should remember that area is pi r square. Okay, area is pi r square. In the first case, I is equal to Vd, drift speed or drift velocity, into E into n pi r square. In the second case, he is increasing the drift velocity to 2v and he is reducing the radius to half. Therefore, I dash is equal to I by 2 ಆಗುತ್ತಪ್ಪ. Next problem. Now here a potential difference V is applied across a copper wire of diameter d and length L when only d is double the drift velocity. Okay, the drift velocity. Now we have one relationship between drift speed and E electric field relaxation time divided by m. Okay, now here we know E is equal to electric field is equal to V by L uppa. Okay, E into V tau relaxation time divided by m into L. Okay, now here if you double the diameter, okay, nothing is going to happen for the drift. A potential difference B is applied across a copper wire of diameter d and length L when only d is the drift velocity. What happens to drift velocity? Nothing is going to be changed. Okay, V is same as V dash. Okay, it does not change. Okay, this relation you have to remember. Vd is equal to E tau by m. Understood? Next problem. In this problem, he is saying when a potential difference is applied across the ends of a linear metallic conductor, what happens? Group of free electrons are accelerated. Free electrons never get accelerated. This is wrong. Group of electrons are accelerated continuously. No, this is also not true. Group of electrons acquire a constant drift. Yeah, this is the right answer. Okay, constant drift velocity from the lower potential to the higher potential. Okay. Now, for example, if this is a conductor, okay, this is at higher potential, this is at lower potential. Okay, higher potential, lower potential. Electrons will be, okay, it maintains a constant drift speed. This is the right answer. Right. Next problem. The answer for this one is C. Now this problem, in a neon discharge tube, okay, we have one discharge tube, neon discharge tube. Here, okay, positive ion, that is positrons. Okay, positrons. In a neon discharge tube, positrons are moving. This is positrons. Move toward right. Okay, this is positron, right. Okay, okay, tube. Okay, neon, then E plus ions move to the right, positrons, okay, while electrons, these are electrons, okay, which are moving towards left. Okay, which are moving toward lefts. Now we know that I is equal to Q by T, and that is nothing but Ne by T. Understood? Now I, this is what? This is nothing but positrons. I can write this as E plus, and these are what? Electrons. This is E minus. Okay, now for positrons we'll find I E plus is equal to N E plus E by T, and for this for positrons, neons. Okay, and for electrons it is I E minus equal to N E minus E by T. Right. Okay. Now what is the total current? current will be always flowing like this, okay, opposite to the electrons. Okay, I is equal to what? I is equal to IE plus IE minus. Now add up this one, N E plus E by T plus N E minus E by T. Okay, now which is common, you can take E by T as common here. Now you can write N E plus N E minus, right? Now you can calculate the value of current. I is equal to 1.6 into 10 to the power of minus 19. Okay, that is equal to, that is we have to calculate per second only. This is per second is by 1. And how much is Ne plus 2.9 into 10 to the power of 18. And then how much is Ne minus 1.2 into 10 to the power of 18, right? This also you can take common. I is equal to 1.6 into 10 to the power of minus 19 into 10 to the power of 18. Okay, how much is 2.9? But is how much? Add this one, 2.9 plus 1.2, that is you are going to get 4.1. Okay, 4 16s are 64, that is you are going to get I is equal to 0.66 amperes. Okay, now here you can guess easily. Okay, 4 into 16, 4 16s are 64, that is little bit more, that is 0.66 amperes. Now how the current flows? Current always flows towards right, towards right. Okay, this is the right answer, 0.66 ampere towards right. This is neon discharge tube. Next problem, there are how many free electrons? 8.4 into 10 to the power of 22. Okay, free electrons per centimeter cube in copper. The current in the wire is so much. Then the drift velocity. Okay, drift velocity. We know I is equal to what? I is equal to V naught upon VE NA. Okay, suffix T, that is drift velocity. Drift velocity. Okay, what you have to calculate? You have to calculate the drift velocity. That is VD is equal to I divided by ENA. Okay, how much is I? They have given 0.21 amperes divided by, we know E how much, 1.6 into 10 to the power of minus 19 into N. Okay, free electrons, how many free electrons are there? You have to be careful here, per centimeter cube is there, therefore you have to write 8.4 into 10 to the power of 22 into 10 to the power of minus 6 in the denominator. When it comes to the numerator, plus 6 agutte into area. Area how much they have given? This velocity where cross section how much? Area is 1 mm. 1 mm andre estu? 1 into again 10 to the power of minus 6. You have to be careful. You have to convert this into meter square. This you have to remember. Okay. Okay. Understood? Here N is how much they have given? N is equal to 8.4 into 10 to the power of 22 per centimeter cube is there. To convert this into per meter square, 8.4 into 10 to the power of 22 divided by 10 to the power of minus 6. If this comes to the numerator, plus is agutte, ಇದು area meter square ಅಲ್ಲಿ ಬರಬೇಕಪ್ಪ. Okay, this 10 to the power of plus 6, 10 to the power of minus 6 gets cancelled, and you can write Vd is equal to how much? That is equal to 0.21, right? 0.21. And I told you this can be written as what? This can be written as 25 by, I told you yesterday that 1 divided by 1.6 into 10 to the power of minus 19 andre estaguttappa, 6.25 into 10 to the power of 18 agutte, right? Okay, there is nothing but 25 by 4 you can write. 25 by 4 into 10 to the power of 18 also you can write. Understood? Into 25 by 4 agutte. okay, this, okay, into 8.4, understood, into 10 to the power of minus 22 is already there, and into 10 to the power of 18. Okay, Napa, Vd is equal to, you can just how many times I can write 0.21 into 25. 0.21 into 25 is how much you are going to get, around 5.25. 5.25 divided by 4 into 8.4. 4 into 8.4 is approximately 33.6, okay, into how much is this, 10 to the power of minus 22 plus 18. Minus 22 plus 18 is nothing but 10 to the minus 4. Understood? That is equal to Vd, how much you are going to get, approximately 5.25. 5.25 divided by 33.6 is approximately, you are going to get 0.15. Understood? 1.5 I can write, that is equal to 1.56 into 1.56 into 10 to the power of minus 5 meter per second, you can write. Understood? This is very easy problem, but here you have to be careful. Okay, here you have to be careful. 5.25 by 33.6, okay, 5.25 divided by 33.6 will give you approximately 0.15. 0.15, this again 1.56 is the right answer. Okay, this is the right answer. You have to do like this. Next problem we'll do. Now here he is asking, assume that each atom of copper contributes one free electron. Okay, now here for doing this problem we know that what is I is equal to Vena, VENA. Understood? This is the drift speed. Drift speed is given by what? Vd is equal to I divided by ENA. Where what is N? Electron density. Okay, electron density in this case will be electron density. Understood? Electron density in this case will be N is equal to Avogadro number into density divided by atomic mass, because they have given everything. Density they have given, atomic mass of copper they have given. You have to use this formula for calculation of N. Now how much is Avogadro number? We know 6 into 10 to the power of 3. And how much is they have given the density? Density they have given 9 gram. You have to convert that into 9 into 10 to the power of minus 3, okay, into 10 to the power of plus 6, right, divided by how much is the atomic mass? 63 into 10 to the power of minus 3, right, okay, that is equal to, you are going to get, if you simplify this one, you are going to get 0.86 into 10 to the power of 29 per meter cube you are going to get. Okay, electron density, that is N. Now you have to substitute this value of electron density here. Vd is equal to I, you know, I is how much? 1.1 divided by, this is 1.6 into 10 to the power of minus 19. Understood? And how much is N? Just now we calculated, that is 0.86 into 10 to the power of 29, right, and that is equal to how much is the area? Pi r square. Pi into how much is the radius they have given? They have given the diameter. If they have given the diameter, you have to divide it by 2, that is 0.5 into 10 to the power of minus 3 the whole square. Now if you simplify this one, you are going to get approximately 0.1 into 10 to the power of minus 3 meter per second. Now, in these kind of problems, okay, it is a trap. If you remember the answer, it will be good for you. Okay, 0.1 mm per second, point m, that is Vd is equal to 0.1 mm per second. Okay, each raw problems you have to remember upon. Okay, as soon as you see any problem on this okay type of equation, if you remember the answer, it is very good because it takes a lot of time to simplify. Just remember I is equal to v na. Okay, from here you have to calculate drift velocity. To calculate drift velocity, first you have to calculate electron density. You should know what is Avogadro number, all those things. First you have to calculate n. After calculation of n, you have to calculate. In this previous problem also, okay, you have to okay calculate it very clearly, then only you'll get the answer. Okay, be careful in these kind of problems. Okay, these are called the level 2 problems because you have to work out. You have to question, okay. I'm going to stop here. If you like my video, kindly okay ask doubts in the comment box, like it, share it, and subscribe it, and kindly refer to your classmates and friends. I wish you all the best. Thank you, one and all.